Welcome to the DIY Honda Garage channel. Welcome to the diagnostic presentation for DTC P0102 related to the MAF sensor circuit low voltage for the Honda Civic models from 2006 to 2011. The DTC, or Diagnostic Trouble Code, indicates a problem with the mass airflow MAF sensor, which is crucial for measuring the amount of air entering the engine. The information we'll cover today will help you accurately diagnose and resolve this issue. Understanding the cause of this error is essential for maintaining optimal engine performance. We will walk through the details of the component affected, possible causes, symptoms, and a step-by-step troubleshooting guide. Let's begin by exploring the specifics of the error code. The MAF sensor, or mass airflow sensor, plays a vital role in the engine management system by measuring the volume of air entering the engine. It is typically located in the intake system, just after the air filter. When the system indicates DTC P0102, it generally signifies low voltage being detected from the MAF sensor, potentially indicating a wiring or sensor issue. This low voltage can lead to incorrect air-fuel mixture calculations, negatively affecting engine performance. Therefore, addressing this issue promptly is essential to avoid potential engine damage or poor fuel efficiency. Understanding the MAF sensor's placement and function is critical for effective troubleshooting. When diagnosing for DTC P0102, several potential causes should be considered. A faulty MAF sensor could be at the core of the issue. It may not be functioning properly, leading to inaccurate readings. Additionally, wiring issues such as shorts or breaks in the cables connecting the MAF sensor to the engine control module, ECM, or power source can lead to low voltage readings. It's also important to inspect for poor connections at both the MAF sensor and the intake air temperature, IAT sensor, as loose or corroded terminals can disrupt signal transmission. Thoroughly investigating these possibilities will assist in pinpointing the exact source of the problem and enable timely and effective repairs. The symptoms of DTC P0102 can manifest in various ways, significantly affecting the vehicle's performance. One of the most noticeable symptoms is poor engine acceleration and overall performance due to the compromised air-fuel mixture calculations. Drivers may also experience increased fuel consumption as the engine struggles to adapt to incorrect airflow readings. There is also a heightened risk of engine stalling, particularly during idle or low-speed conditions. Recognizing these symptoms is essential for timely diagnostics. If you notice any of these irregularities, it's advisable to run a diagnostic check immediately. Understanding these symptoms helps you approach the troubleshooting process with an informed perspective. The first step in troubleshooting DTC P0102 involves turning the ignition switch to the on first position and waiting for 2 seconds. This action powers up the vehicle's electrical system, allowing components to initialize. After this brief wait, it's essential to record any freeze data and onboard snapshots, as they can provide critical information capturing the conditions under which the fault occurred. These preliminary observations can be valuable for understanding the error better. Performing this step correctly sets the foundation for the subsequent diagnostic checks. In the second troubleshooting step, utilize the Honda Diagnostic System, HDS, to check the MAF sensor data from the data list. You are looking specifically for readings around 0 grams per second or 0.1 volts or less. If the MAF readings are within these limits, it indicates a significant issue needing immediate attention. If the readings are indeed at or below these specified values, proceed to the next step in the troubleshooting process. Conversely, if readings are normal, the issue may be intermittent, suggesting the system is functioning correctly at that time. In such cases, a visual inspection for poor connections or loose terminals at the MAF and IAT sensors, as well as the ECM, PCM, is warranted. This step requires you to turn the ignition switch to the lock 0 position. Effectively, this action powers down the system, allowing for safe disconnection of components without risking any electrical shorts or other complications during subsequent diagnostics. Preparing to check the fuse is a crucial next step, ensuring that the electrical circuit to the MAF sensor is functional. This precaution helps to establish whether the issue may stem from other components in the electrical system. Safety should always be a primary concern when conducting electrical diagnostics, so ensure that you have adequately powered down the system before proceeding. In this fourth step, check the number 3 alternator fuse, which is a 10-amp fuse located in the under-dash fuse relay box. This fuse plays a significant role in powering the MAF sensor and the intake air temperature sensor, IAT circuit. If you find that the fuse is intact and functional, you'll proceed to the next troubleshooting step. Conversely, if the fuse is blown, it indicates a possible short in the wiring between the MAF IAT sensors and the fuse. In such a case, repairing the short circuit is essential, followed by replacing the blown fuse. Locating and checking this fuse can provide immediate insights into the electrical integrity of your system. The fifth troubleshooting step requires you to disconnect the 5P connector from the MAF sensor IAT sensor. This is an essential procedure before taking electrical measurements to avoid any interference that could lead to inaccurate readings. By isolating the sensors, you ensure that the voltage measurements taken in the subsequent steps directly relate to the sensor's performance without other variables affecting the findings. Be cautious when handling the connector. Ensure it is clean and show no signs of corrosion or damage before reconnecting later. After disconnecting the 5P connector, turn the ignition switch to the on position again, activating the vehicle's electrical system. At this stage, make sure that the rest of the dashboard lights are functioning, which indicates that power is reaching the system. This step is crucial as it prepares you to measure the voltage across the MAF IAT sensor terminals accurately. Incorrect voltage readings could lead to misdiagnosis, so it's imperative to ensure the system is prepared for an accurate assessment. Before proceeding, double-check that the vehicle is in a safe condition to avoid any electrical hazards. In this step, measure the voltage between terminal number 5 of the MAF IAT sensor 5P connector and body ground. This measurement is crucial as you are looking for the presence of battery voltage, indicating that power is correctly supplied to the sensor. If the measurement shows that battery voltage is present, you can confidently move on to the next step. Alternatively, if the voltage is not present, it indicates an open circuit in the wiring between the number 5, 3 alternator fuse and the MAF sensor/IAT sensor. A lack of voltage here can further complicate the system's performance, emphasizing the importance of this diagnostic check. For this step, you need to turn the ignition switch to the lock 0 position once again. This action is crucial as it powers down the electrical system, allowing for safe measurement of resistance without risking damage or incorrect readings. After ensuring that the ignition is off, prepare to measure the resistance across terminal number 3 of the MAF IAT sensor, 5P connector, and body ground. This measurement will help determine if there's an appropriate level of resistance, which should be between 190 to 210 kiloohms. Achieving accurate resistance readings is vital for identifying whether the sensor is functioning correctly. If not, it will guide you to further diagnostics. In this final troubleshooting step, Measure the resistance between terminal number 3 of the MAF sensor/IAT sensor 5P connector and body ground. For a properly functioning MAF sensor, this measurement should fall within a range of 190 to 210 kiloohms. If it meets this criteria, then the sensor's internal circuitry is intact and the issue may lie elsewhere, likely requiring additional exploration or verification. If the resistance is outside this specified range, it indicates a malfunction within the MAF sensor itself, necessitating replacement or further testing of the circuit. Eligibility of the resistance values helps identify whether the sensor requires immediate attention. Once all repairs and checks have been made regarding the MAF sensor and circuit related to DTC P0102, it is crucial to perform a final verification. This involves confirming that all repairs have been duly completed and verifying the efficiency of the fixes by retesting the vehicle's functionality. Utilize the HDS once more to ensure there are no remaining trouble codes present and to check that the MAF sensor operates within normal parameters. Each step should have been thoroughly validated before concluding that the issue has been resolved. Preventing future occurrences may involve maintaining electrical connections and keeping the MAF sensor clean. Ensuring these checks helps enhance long-term vehicle reliability. To prevent future occurrences of issues similar to DTC P0102, routine maintenance of the MAF sensor is essential. Regular cleaning of the MAF sensor can help to maintain accurate airflow measurements, which is critical for optimal engine performance. Additionally, conducting periodic inspections of the electrical connections associated with the MAF sensor and the IAT sensor can prevent loose or corroded terminals that may compromise the circuit's integrity. Keeping the air intake system clear of obstructions is also vital, as obstructions could lead to erratic readings. Implementing these preventive maintenance practices helps enhance reliability and prolongs the lifespan of the vehicle components. In conclusion, addressing DTC P0102 requires a solid understanding of the MAF sensor's function and its role in the vehicle's engine management system. Following a systematic troubleshooting approach, as outlined in this presentation, ensures that you can accurately diagnose the underlying issues. Remember, the potential causes, like faulty sensors or wiring issues, need thorough checks, and the symptoms can significantly affect vehicle performance. Moreover, adopting preventive practices can help to enhance the longevity and efficiency of your Honda Civic. Ultimately, prioritizing timely and accurate diagnostics ensures the optimal functioning of your vehicle while maintaining driving safety and efficiency. Please like and subscribe to the channel. See you next time.